Alright, so we're going to talk about quadrilaterals and polygons today. And again, these are all things that you should have talked about to some extent in the past. So I have this diagram, this flow chart, if you will, up on the board. So as you're copying that down, I'm just going to go through characteristics of each of these pieces. So they're all centered around the quadrilateral, which is just a four-sided figure. And there are three types of quadrilaterals. There are trapezoids, which if you look at the trapezoid, a trapezoid is defined just as a quadrilateral with exactly two parallel sides. So it's one set of parallel sides or exactly two parallel sides. So in both of those examples, they are the top and the bottom. On the other side of the trapezoid is the kite. And a kite has two sets of congruent sides, but no parallel sides. So if you notice, both the top sides are congruent and both the bottom sides are congruent, but there are no parallel sides. Most of our time we were going to spend with parallelograms. So down below, we have the parallelogram, which has two sets of congruent and parallel sides. So the top and the bottom are parallel and congruent. The left and the right are parallel and congruent. There are two types of parallelograms. The first is the rectangle, which is a parallelogram that has four right angles. Then you have the rhombus, which is a parallelogram with four congruent sides. There is one particular rectangle and rhombus that is actually both, and that would be the square. So the square is a parallelogram, so two sets of parallel sides, that has four right angles and four congruent sides. So rectangles and rhombuses will only overlap with a square. Otherwise, rectangles only are parallelograms with four right angles, and rhombus is a parallelogram with only four congruent sides. So make sure to copy that down. I'm not going to make you copy the definitions of all of these things, because again, I think these are things that you should have known from the past. So once you have that down, we are going to move on, and we're going to talk about all types of polygons. We're going to make sure you know the names of the first several. So we're going to create a little table with the number of sides. And what the polygon is actually named. So three sides, I think you all know by now, those are triangles. Four sides would be quadrilaterals. So we don't name particular quadrilaterals, we just say it is a quadrilateral. Five-sided is a pentagon. Six is a hexagon. 7 is what we call a heptagon. 8 is an octagon. 9 is what we call a nonagon. And 10, I'm not sure if you can see that still on your screen or not, but it is a decagon. So that 10 went out of the screen there a little bit, but it's called a decagon. So D-E-C-A-G-O-N, which is like a decade. Now, 11 is called an undecagon, that's U-N, and then decagon, and 12 is a dodecagon. So we won't spend a lot of time with those, but just in case you're curious, they do have names for some of them beyond 10 as well. So please be familiar with these. How many do I have listed there? These 8 names of polygons. These are ones that you will be quizzed on, and I will expect you to know these names. You need to know that a 7-sided figure is a heptagon, 8 is octagon, 9 is nonagon, and 10 is decagon, because I think those first 4 you should know. And even octagon and decagon you may know. It's the 7 and 9 that are probably new for you. Now we're going to do the rest this time, and there's not a lot to do with these. Again, like I said, you should have known most of these, but there is one piece that we are going to talk about that I don't know that you've talked about before, and that would be the interior angle measures of polygons, so beyond triangles and quadrilaterals. So I think you guys are probably familiar with the fact that triangles have 180 degrees on the inside, and quadrilaterals have 360 degrees on the inside. What we do is there's this method or process. So for instance, if I were to draw a regular hexagon, or not even a regular hexagon, just a hexagon, and I pick one of my vertices, and I draw lines to the rest of the vertices. So I draw a line to here, a line to here, and a line to here. There's already a line to here and here. I created 4 triangles. 1, 2, 3, 4. Notice there are 6 sides. We formed 4 triangles. If I did it with an octagon, so I chose this vertex and drew lines to the rest of the vertices. 8 sides, 1, 2, 3, 4, 5, 6 triangles. Every triangle has 180 degrees inside of it. So to figure out how many degrees are inside this thing, we would just take 4 times 180 degrees. That's actually going to get me 720 degrees. Over here, we would take 6 times 180 degrees. So we'd have 6 times 180 degrees. That's going to get us 1,080 degrees. So there's a formula that we can learn out of this. If you want to find out how many degrees are inside a polygon of any number of sides, doesn't matter how many sides it has, what you do, so we call this the interior angle sum. You take n minus 2 and you multiply it by 180 degrees. And we're just going to say where n is the number of sides. So as many sides as you have, you subtract 2 of them, because we saw 8 sides, we created 6 triangles. 6 sides, we created 4 triangles. If you had 100 sides, you create 98 triangles inside. So you take the number of sides, you subtract 2, and you multiply by 180, because every triangle is 180 degrees inside of it. So inside of that thing is 4 triangles. 4 times 180, we get 720 degrees. And so this is what kind of probably the new thing here that you may have not have known before. So I don't know that we need to do a ton of examples on that one, because I think the formula is pretty self-explanatory. The only other thing that I just want to specify is what a regular polygon is. A regular polygon is a polygon where all the angles and all the sides are congruent. So as you move around, a square would be regular because all the sides are congruent and the angles are congruent. An equilateral triangle would be regular because all the angles are congruent and all the sides are congruent. So it's just any shape that has all the same angles and all the same sides would be a regular polygon. The book talks a little bit about tessellations. We're not going to spend too much time talking about that because it's really just kind of repeating a pattern And you can use polygons to create tessellations, but we're not going to spend a lot of time on that piece of it because we are running short for the year anyway. So we're going to spend some more time in class working on this interior angle sum formula, as well as working with some regular polygons.